As we continue with section 3.3, we're going to look at the product rule. Now, the product rule is used to find the derivative of two functions that are being multiplied together. And the rule is quite simple. If both functions f and g are differentiable, and y is the product of functions f and g, then the derivative is the first function f times the derivative of the second function plus the second function times the derivative of the first. So let's take a look at our first example. Okay, so if you want to think about it, this is our first function, and we'll call this one a, because a function is defined as f, and we'll call this one function b. So if I want to find the derivative, okay, it's going to be the first function the way it is, so 2x cubed plus 5, times the derivative of the second function, which would be 6x minus 1, plus the second function, which is 3x squared minus x, times the derivative of the first function, which is 6x squared. Now you're done calculus right there. The rest of this is just simplifying. So I'm going to multiply out these two binomials to get 12x to the fourth minus 2x cubed plus 30x subtract 5. If I distribute the 6x squared, I'm going to get 18x to the fourth minus 6x cubed. And now gathering like terms, I have 30x to the fourth, so that gets rid of those. I have negative 8x cubes. That gets rid of my x cubes. And then I have plus 30x, subtract 5. And there would be my derivative. Again, we're done the calculus right at this stage here. The rest is just simplifying. Okay, in the next example, we have y equals root x times 2 minus 3x. Now, I know some of you might be thinking, why don't I just convert this to x to the 1/2 distribute and use the sum and difference rule? You can, but we are progressing to get questions like this. If I had x squared plus 3 to the fourth times 2x minus 7 to the fifth, you would want to expand that and do a bunch of multiplying and use the sum and difference rule. So we're building to something like this. So we're starting with something a little bit easier. So let's take a look at, first of all, rewriting root x as x to the 1/2 times 2 minus 3x. Again, this is my first function, this is my second, so y prime is going to be the first function times the derivative of the second plus the second function times the derivative of the first. Again, you're done calculus right there, and depending on how far they want you to simplify, some books, they don't make you simplify at all. Some books make you do quite a bit of simplifying. So let's simplify this a little bit. We'll multiply the negative 3 and the x to the 1/2. And I'm going to distribute this onto the first term. So 2 times 1/2 is going to be 1. So I'll be left with x to the minus 1/2. And then minus 3 times 1/2 will be minus 3 over 2. And x to the first times x to the 1/2 is going to be x to the 1/2. Now I have two like terms. I have negative 3x to the 1/2 and negative 3 over 2x to the 1/2. So I'm going to get a common denominator, and I'm going to make this negative 6 over 2x to the 1/2. So now I can combine my like terms. So my first term, x to the negative 1/2, I'll leave as is. And negative 3 subtract 9 would be negative 9 over 2x to the positive 1/2. And there would be your final answer. Now they might rewrite this first term without a negative exponent, which would be 1 over x to the 1/2 minus 9 over 2x to the 1/2. But again, it's the same answer as the one above it. Okay, in our next example, we have an application again, and we're asked to find the equation of a tangent line to this curve at the point 1,5. So again, to find the equation of a tangent line, you need slope and point. We already have the point. The slope is the derivative. To find the derivative, I'm going to use the product rule. So it's going to be the first function, 3x squared plus 2 times the derivative of the second function plus the second function times the derivative of the first. Now, there is your derivative. And because we're evaluating the slope at 1, I can plug 1 in right away. There's no need to simplify the derivative. So this works out to be 5 times 6, 1 cubed times 2, it's 1 times 6 is going to be 6. So my slope is 36. So now I can go to the point slope formula to find the equation of the tangent line. So this is going to be y subtract 5 is going to be 36, x subtract 1. Now, depending on the form they want our final answer in, I'll distribute the 36x. And let's put this one in general form. So in general form, remember, all my x's and all my y's and my constants are on one side, and my x term has to be positive. So I'll subtract the 5 over, and I'll add the 5 over, and there would be my final answer. So again, notice when you're trying to find equations of tangent lines, once you take the derivative, which is done right here, you can plug in your point and evaluate the slope right away. Okay, in our last example, we're given function capital F, and it's the product of small f and small g, and now we're given graphs of functions f and g, and we're asked to, in 21, to find the derivative of capital F at 2. Well, let's start with our basic equation, and we know that capital F of x is equal to little f of x times g of x. So if I take the derivative of capital F, it would be the first function times the derivative of the second plus the second function times the derivative of the first. So now I'm looking to evaluate this when x is 2. So I'm going to plug 2 in for x. So it's going to be f of 2 times g prime of 2 plus g of 2 times f prime of 2. Now to evaluate these, we're going to use our graph. So remember, f of 2, g of 2 are just the y coordinates when x is 2, and g prime of 2 and f prime of 2, those are the slopes of the tangent lines at 2 in those particular graphs. So f of 2, again, f is the darker graph. At 2, f of 2 is 1. G prime of 2 is the slope of the tangent line at 2, and the slope of that tangent line, if I was to evaluate it, would be -1. G of 2 is just the y coordinate of g when x is 2, and that 2 is -1. And f prime of 2 would be the slope of the tangent line at 2. And if we calculate that slope would be 3. So if I work these out, this should be -1, sorry. I end up getting 1 times -1 is -1, 3 times -1 is -3, so this derivative would be -4. Okay, I think I leave the rest of those as part of your assignment, so you can reference that one when you do 22, 23, and 24. Last example, we are looking at a multiple choice question from a previous AP exam. In this question, we are told that functions f and g are differentiable with the following properties. First of all, g of x is positive, f of 0 is equal to 1, and we are told that h of x is equal to the product of f and g, and we're told that the derivative of h prime is equal to f of x times g prime. Now, if we take a look at the original function h of x, we're left with h of x is equal to f of x times g of x. And if we were to do the derivative, we would have h prime of x. It should be f of x times g prime of x plus g of x times f prime of x. Now, if you look at the derivative, we are only, the derivative only equals this part here. So that means that this part must equal 0 if it's not included in the derivative. So we're going to use that to help us determine what the value of f of x is. So we know that g of x times f prime of x has to equal 0. And we are told that the function g of x is always greater than 0, so this part can't be 0. So therefore, the derivative of f has to equal 0. And therefore, we have to try to figure out what f is, okay? So in this particular point, if we look at our choices, the only function that has a derivative of 0 is if my function f is equal to 1. So therefore, the value of f of x would be equal to 1. Okay, that ends part of the product rule. So there's your assignment from the handout that will be provided to you in class and a few questions from the Calc 30 text.